Welcome back to Series 3 of the Atari ST Nostalgia GFA Basic Tour. And we improved our sprite animation quite a lot in the last video, by like a good 30%. And we moved the objects around by using RC copy instead of put commands. And we used the bmove commands with an optimization to actually do a clever cleanup for this performance enhancements. There is, however, something that the put command that we are no longer using does on its own that RC copy actually cannot do. And in this video we will explore what that is and how we have to deal with that situation. And yeah, I was already on an adventure to take a little bit, make a little bit of code, so I'm using RC copy to move this object back and forth on the screen, which looks all nice and smooth. But as you can also see, the object is never leaving the screen, and there's a good reason for that, because also in the sprite animation, my objects were never leaving the screen. And I'm going to show you why that is, because suppose I want this object to leave the screen. So basically, like I did in part 27 when explaining the put command, I am saying, okay, I'm going actually to the left until my coordinate is actually -150. And when I'm going to the right, I'm going like until my object is all the way at coordinate 700. And this is very similar to what I did at the start of part 27. And when I was using the put command, this is no problem at all. It just worked. So let's see what happens if I do the same with the RC copy command. So I'm going to start my program again, and whoa, that looks weird. What the hell is going on here? And here also, there's like, this is totally not what you would expect if you would treat the RC copy like a graphics command. But of course, RC copy is not a graphics command. It's actually a bit operator. It's used to do raster copies within memory, and because it's not a graphics command, it's also not aware of the boundaries that graphics commands should have, like screen boundaries and stuff. It doesn't understand it, and that's very important to understand. You have to understand this, because yeah, since I'm doing stuff in memory, it's all nice. I have a lot of freedom, but it's just copying bytes or bits, and the quirks it has, they looked a little bit similar like the stuff we saw happening in part 21 when we were experimenting with bmove. So the detection whether our object that we put is actually intersecting with the boundaries of our screen is not done automatically. The put command does this completely automatically, but RC copy has no concept of this. It doesn't understand screen boundaries, so we have to do this manually. So we have to sort of do this detection and then use the result of this detection to actually feed back to our RC copy command. And lucky for us, there is a command for us to do this, which is called RC INTERSECT. It's this default function that's in part of GFA Basic. And I'm going to demonstrate it here by just putting a box on screen, putting the number 1 in it, then determining some variables x, y for top left coordinates, and then the width and the height. And based on those, I'm going to draw a second box with the number 2 in it. And then I'm going to print the values of the variables x, y, width and height. Then after a query pass, I'm actually going to use these numbers to do the RC INTERSECT command. And RC INTERSECT, the function, what it basically, it wants 2 sets of coordinates. So an upper left x and y, and the width and the height of the first section. And then you input the x and y and width of height of a second section. And the first section can just be numbers. But the second, the last 4 numbers, they have to be variables, because it's going to determine the intersection, and then it's going to write the values of the intersecting part into those last variables. So it will not output any new variables, it will change the variables that you put in, because it's a function. And in this case, I'm going to use the function determine like 100, 100 with a width of 300 and a height of 100. Which are the dimensions of the first box I was drawing. And I'm going to determine the intersection with the dimensions of the second box I was drawing, which are based on these x, y, w, and h variables. After I perform this function, I'm going to show the new values that it wrote into the existing variables. And then I'm going to write a black box, so draw a p box based on those coordinates. So I'm using the output of the variables, in this case as input for a p box command. Because RC INTERSECT is not bound to the RC copy command, even if they start with the same 3 characters. The RC INTERSECT command just alters variables based on an intersection analysis, and you can use those variables any way you like. So in this case with the pbox command, and later we're going to use that as input for an RC copy command. So this is how it looks. So the 2 boxes are here, and you can see the x, y, w, and h are exactly like I set them in the program. And after I did the RC INTERSECT function, you can see that the X and the Y remained the same, because the upper left corner of box 2 is actually inside box number 1, so that's to be expected. We can also see that the width and height are actually altered. So the width of the intersecting part is only 200 pixels out of the 300, and the intersecting part of the height of the box is only the 50 pixels instead of the 100 that the full box size was. And based on those variables, yes, the P box now shows the intersecting part between the two boxes. And this is, by the way, also the example that's given for this command inside the GFA Basic interpreter manual. So some people might recognize this. And you can see, yeah, it works, and it's sort of a good way to learn the command, learn the function. So what if we want to use that as input for our RC copy command? Everything in this code is almost exactly the same. So I'm determining like my start coordinates with the width and the height of my object. And then before I actually put my object on screen, I'm going to set the input variables for my RC INTERSECT function, because the RC INTERSECT function is altering the existing coordinates that I put in. I cannot use my coordinates because my coordinate system doesn't need to be messed up by this command. This is just based on increasing or decreasing the X move, and this one actually will stay constant. But every time I will determine the IX and IY as input for the command based on the coordinates that I calculated, and then also set the width and the height back to the default values. Then I will do a VSync and do a B move to clean up like we did in part 29. And then I'm going to do the RC INTERSECT function, and in this case based on the boundaries of my whole screen in monochrome. So from the upper left at 0.0 with a width of 639 and a height of 399. And I'm going to determine the intersection between that and the coordinates of my object, which now are like IX, IY, so the X and Y coordinates of my object and the width and the height of my original object. And the RC INTERSECT function will actually change these four variables to say, okay, but this is the part that's actually intersecting with the screen in this case, or intersecting with the coordinates you gave. And based on that, I'm going to perform the RC copy command. And the RC copy will basically be, I'm going to look in the sprite buffer and I'm going to grab an object, in this case at the coordinate X, which is 400, but I'm adding this, and as long as it's anything positive, the X move and IX will actually be the same. Unless it's of course outside of the screen, but then it will not perform this command. So basically the minus X move plus IX, this will always be 0. But if X move, my coordinate is negative, this will mean, for instance, if it's negative like minus 3, it will grab at coordinate 400 minus 3, which is so plus 3, plus the value of IX, which in that case will be 0. And that means it will grab the object minus the first 3 pixels. And the width of the object will also be a little bit smaller, so instead of 96 it will be 93. So it basically only takes the last piece of the object and puts that to the left of the screen, creating the illusion that actually the other part has left the screen. And I'm going to do the same for the Y coordinate. And then the input is basically like IX, IY, put it there in the buffer screen, and this works. This looks a bit confusing, but actually it's quite logical. So this is now how it looks, and as you can see, it creates the illusion that the object is actually leaving the screen, which it actually, technically it is not. It's just putting only the intersecting part of the object on the screen. And so if it's outside of the screen, it's only putting that small part. And that creates the illusion that it's actually leaving the screen. And the cool thing is, now I'm using the intersect based on the complete screen boundaries, but I don't have to do that. I can basically put any boundary I want as the input, and that's something I want to show and play around with. Because now this is exactly the same, but for the boundaries for the RC INTERSECT, I actually chose different coordinates. In this case, 200, 184 as the up left coordinates, a width of 239 and a height of 32. And then the formulas themselves, everything is exactly the same. But as you can see now, because the intersection area that is determining is much smaller, which means I can do some clipping to move this object around. And unlike like a clip command, which basically sets the clipping for all graphical output, this clipping in this formula is only done for this object. So I could do this formula for this object and then do another RC INTERSECT for a different object with different coordinates and even also a different clipping boundary. And I can do it both at the same time, so independent of each other. And that's actually the extra freedom that the RC INTERSECT command with RC copy gives me compared to something with like a get and put command. So that's actually really cool. And yeah, now I'm still using the full height of the object, but I can actually show by altering the coordinates a little bit. For instance, here, if I keep the same coordinate, but a height of like 16, and for the movement back, I'm actually also going to use a height of 16, but with a different coordinate, like in this case 216, which means when the object is moving left, you will only see the top half of the object, and when it's moving to the right, you will only see the bottom half of the object. And you can see I only had to alter the clipping, so the boundaries that I'm used for the clipping, and the rest is taken care of by the routine I wrote already. And this is like pretty cool. And you can do the same, like if I only want to have the middle 16 pixels, it basically means in here instead of 200 I say, okay, let's say like 192. And for the other one also, instead of coordinate 184, I will do 192. So I will clip from the 192, and the height I will do, it will still be 16. And as you can see, that also works. So it looks a bit, yeah, at first the function looks a bit intimidating, especially since it's altering the variables that I'm putting in. So it's a bit tricky to use, but once you got the hang of it, you can see it's actually fairly easy to use. Of course, if I want to use this for my sprite animation, it means I have to do this RC INTERSECT 12 times, because I have to do it for every coordinate of all the sprites, which will make the code look a bit complicated, and it might also be, yeah, it might cost a little bit of performance in this case. So I would still say, yeah, if you can avoid it, just avoid having your objects outside of the screen, keep them inside with any demo, play thing, toy you create, or any game you make. This is just the easier way, is just to keep the objects in the screen. But if you have to make them outside of the screen, this is a fairly easy method to determine the clipping for your object, the intersection, and then draw your object yeah, accordingly. And with that, this video has already come to an end. So it's a bit shorter than the other ones, which yeah, and every time we were already like 20 minutes in a very early stage. But this is just, the command is not that complicated. But the cool thing is, yeah, it's not limited to screen edges. You can do it, yeah, based on, you can do it for different objects with different clipping coordinates, which is like really cool. And it's not bound to use with RC copy, because before we used it with pbox already. So the two commands are not really bound to each other. But yeah, we learned how to use the RC intersect function to determine and use intersecting coordinates as input for different kinds of commands. And in the next video, we will look at whole screen animations, like how can I move the whole screen, but still in a very smooth way. So that should also be pretty cool. But that's something for the next video. For now, for this one, I would like to thank you for watching. Hope to see you next time.